Hi folks, Mr. Long here. I've got a screencast on how to solve problems with quadratic equations using all of the work that we've been doing in class the last couple of weeks. So the first set of problems are projectile problems, right? They're just they're problems that are objects being thrown through the air, and the path is obviously represented by a parabola, the equation of a quadratic. So in our first case, we have a toy rocket being fired into the air from the top of a barn, and its height is given in the equation -5t squared plus 10t plus 21, and the height's in meters. Time is in seconds and height is in meters. So the first thing we want to do in part A is to draw a sketch, and I guess some key things here that we know just from the equation is that we know that the parabola is negative, like the a value is -5, so it's opening down, it's frowning, and we also know the y-intercept is 21. So let's draw a sketch of this. Okay, let's draw a sketch. So here's what our sketch. You may hear my dog. Sorry if she barks or anything. She's with me right now, and she's looking for some attention, I think. Okay, so here is the parabola. So that's the path of the toy rocket. We know that this is height on the y-axis and time on the x-axis. This right here would be the starting height, which is 21 meters. That would represent 0 meters in height there and 0 seconds in time. This right here would represent the maximum height, right? And then this would be the time for the maximum. And then right here, when the height is 0, that's when it hits the ground. Okay, those are the three key features. By the way, what you can do here, folks, is you can pause it, remember, at any point in time, rewind it, go over things. I do think you should have a calculator out when you're doing this and working through the calculations as I am. So anyway, so what you see again here is, so the ball is released, or the toy rocket is released here from 21 meters, which is the top of a barn. It goes up and up and up till it reaches its maximum height, and then it falls to the ground, and the ground is at 0 meters. Okay, the ground is at 0 meters. And this represents the y value of the maximum, that's the maximum height at the vertex, and that's the maximum time value. And okay, so, and then of course the ball hits the ground right there, folks. So let's start solving these problems. What was the maximum height of the rocket? Well, once again, we're going to use this property, that I know that if I get the x-intercepts of a simpler parabola, so I can do this, 0 equals -5t squared plus 10t. Right, I can do that, and I can figure out what the x-intercepts are of that, forgetting about that plus 21. And I know that the middle of those x-intercepts is going to be the vertex for the original graph. So 0 equals -5, and then t multiplied by t plus 10 multiplied by t, and then I can get a common factor, which is just t. So I remove that common factor, t, bring it to the front, and then I have -5t plus 10 equals 0. And I'm just going to move this screen up a bit here. So now what I have to do is, let's see, I want to get this bracket, or this t, so that t can equal 0. And the other t would be -5t plus 10 equals 0. And I'm going to add 5t to both sides. So I'm going to have 10 equals 5t. Right, that gets, basically it's like moving it over to here. And then from that I want to divide by 5. So what I'm going to do right now, folks, I'll highlight this. I'm going to move this up to here, okay? And I'll write in red now. So I know one x-intercept is 0, and the other one is 2. So which one, what is the vertex then? Well, if one x-intercept is 0, or t-intercept is 0, another one is 2, then halfway between them is 1. So t of the vertex, which is like x of the vertex, right, equals 1. So that's 1 second to reach the maximum. Well, how do I find out the associated y value, or in this case, height value? Well, I'd have to substitute into the formula. And I'm going to have to do that, folks, unfortunately, down here, okay, down below. So I know the height at 1 second will be -5 times by 1 squared plus 10 multiplied by 1 plus 21. And that equals, well, 10 times 1 is 10, plus 21 is 31. 31 minus 5 is 26 meters of height. Okay, 26 meters of height, which actually matches the answers there. So in all these problems, you're going to be doing the same thing, actually. You'll be finding the vertex first, and then once you find the vertex, you're going to use it to solve. So the thing that we have to do now is to figure out when this rocket hits the ground. Okay, when does it hit the ground? At what time period does it hit the ground? So here's what I know. Let's draw our sketch, and I'll maybe draw it over here. So when I draw my sketch, I know that at 1 second, it's at a height of 26 meters. And then it comes down and hits the ground, right? Right there. So I want to figure out that value. So how do I do that? Well, I know my delta y. If I do my slope diagram, my delta y is -26, right? It decreases by 26. I also know from my formula that the a value is -5. That's the number that's in front of the t squared. Okay, so let's look. What is our formula? Well, I know that delta y equals a delta x squared. Now, I should be careful here. Really, I have, instead of y, I have height. Instead of x, I have time, but it means the same thing. So delta y is -26, a is -5, and delta x squared. So what I need to do is to divide both sides by -5, and that gets rid of that -5, and that goes in 5.2 times, and that's delta x squared. So then delta x is the square root of 5.2. And the square root of 5.2, sorry, .28. So it's 2.28. And then what I need to do is, if I think about this, maybe I'll just draw it on here. I'm at this location, and that's at 1 second. And now I figured out that delta x goes to the right by 2.28, right? So delta x, so, and that's the t value, right? The t-intercept, rather. So let's call that, instead of, so delta x is really delta t, my apologies. So t2, which is, I'll just show you, that's t2 over there, right, to the right. So t2 is going to equal 1, because that's the x value of the vertex, or the t value of the vertex, plus delta x, which is 2.28. So that equals 3.28 seconds. Okay, 3.28 seconds. Okay, so we've worked through that. We found the vertex and the x-intercept. So that's how you do that, folks. What I'm going to quickly do, but I just want to turn to the second page here, and the only thing I'm going to do here is get you started on the profit problems and make sure that you actually understand what they're about. So these problems here that we're going to look at relate profit and advertising. So specifically, it's if you've got a graph like this. And then you've got a curve like so, a parabola. This represents profit. Profit is how much money a business makes, right? If it's positive, they earn money, they're making a profit. And profit is how much money they have that exceeds the amount that they spend, right? It's how much you take in versus how much you actually spend. So we call these locations here, they're the break-even locations, right? That's when they have zero profit, the x-intercepts. And in this case, x right here, the x value right here is how much money they spend on advertising. Right? This is how much they spend on advertising. So if you're wondering, why is it a curve like this? Well, I want you to think about something as simple as, selling pop, right? Or soft drinks or juice, right? If you're over here in this area, and I'll just talk through this, and please, you might want to pay attention to this, pause, rewind, but if you're in this area, you're not doing any advertising at all, hardly, right? So you're going to lose money because no one knows about your product. If you're right here, you might be doing just a little bit of advertising, and you're breaking even. In other words, the amount you're spending on advertising isn't very much, but at the same time, you're not making a lot of profit because you're not selling as much. So over here, you're not advertising very much, and you're not selling very much because this is advertising, right? As I move along this axis, left to right, I'm spending more and more on advertising. And here to here, my profit goes up. So I spend more on advertising and more on advertising and more on advertising and more on advertising, and I'm selling more and more and more, so my profits get higher and higher. But I reach a point at which the extra advertising, and they call this the saturation point, really, I'm spending more and more on advertising, but I'm not getting any more sales, right? Since I'm not getting any more sales, that's a cost that keeps growing and growing and growing, but I don't have any extra money coming in, so my profit goes back down. So eventually I reach a point where I've spent so much on advertising that I'm breaking even again. The amount of money I'm taking in from sales is matched by how much I'm spending to run my business. And then in this area, I'm losing money. Okay, I'm losing money. And that's not good either, because I'm spending so much on advertising that it's actually more than the amount of money I'm making. So this represents the maximum profit, and X down here, this X vertex represents the advertising that results in the maximum profit. These locations here and here, the x-intercepts, x1 and x2, represent what are called break-even or zero profit levels, right? I'm not making any profit at all. Okay, you may want to look over that again. You're going to notice that these equations, everything is in thousands of dollars, so you're going to end up with very, very large numbers. And you don't have to add on the 1,000, just you can write the word 1,000 in your solutions. Okay, so you're going to want to come back and look at this parabola again. But the big idea here, folks, is not much advertising, so not much sales. More and more advertising, so more and more sales, so profit goes up, and then eventually you reach a point where the extra advertising isn't giving you any extra sales, but the cost of that extra advertising is so much that there's not much left over. So, again here, and I've got answers for you, right? So here it just says what is the maximum profit. So you use the same strategy. You're going to do your partial factoring, like set 0 equal to, I'll maybe start this one, but you can do this one yourself. I'm totally confident you can do this by yourself. For this one, you're just going to go 0 equals negative 5 x squared plus 550x. And again, get the x value of the vertex and the y value of the vertex. And then the answer is right there, what the maximum profit is, which is the y value, and then it tells you the advertising level. Okay, folks? So then there's 2 pages worth of questions. There's the 2 examples. You need to finish this, obviously this example number 4, but there's also a few more questions for the projectile problems as well. Okay. Okay, it's the same strategies every time. I'm getting you to apply what you've learned in terms of graphing to figure out the vertex and to figure out x-intercepts in order to solve problems. Okay, and the answers are all there for you, and you do need to finish this today or tonight. You can expect, because we are going to have a test on Thursday this week, you can expect that this stuff will be on the test for sure. Okay, good luck, and just try and get that done for tomorrow.